Okay, we are going to look at the last section of Unit 4, Part 1, Assignment 1. And today we're going to look at how you judge design and implementation of a programming and a coding project, what it is you use to judge the quality of software applications. So, when faced with the same problem, different programmers can arrive at very different solutions. This usually occurs because problem solving is a very personal process, and most programming languages have enough flexibility to permit a variety of solutions for the same problem. However, the actual design and implementation of the software solution has a direct impact on its overall quality. The quality of a software solution is judged by assessing its efficiency or performance, maintainability, portability, reliability, robustness, and usability. So first of all, we're going to look at efficiency or performance. The performance of an application is usually assessed by measuring the system resources consumed by the program. For example, CPU clock cycles, processor time, allocated RAM, and the rate at which storage media is read from and written to. A complex process may be CPU intensive. It may be possible to revise the program code to be more economical, which in turn may improve performance, make the program work faster, and use fewer resources, such as the RAM, the memory, and so on. This type of revision is common in programs which rely on speed, such as video game programming, where screen frame rates can suffer due to inefficient coding, or taking external devices in real-time systems where timing issues can be critical, for example, traffic control systems or missile guidance systems. Next comes maintainability. Maintainability is the ease with which a program can be modified by present or future developers in order to carry out corrective, perfective, and adaptive maintenance. Corrective maintenance is fixing an error or a bug that has been identified. Perfective maintenance is making an improvement to a program that enhances its performance. And adaptive maintenance is making modifications to a program by adding, changing, or removing functionality to reflect changing needs. So, for example, in a finance package where the VAT is calculated automatically. So let's say the government changes the VAT rate. It may mean you need to adapt the code in your program so it's accurate with the new VAT rate to be calculated, for example. Portability. Portability is the measure of a number of different computer platforms that the source code can target, such as hardware, operating systems, and so on. Some programming languages, such as C, are particularly portable, as they have compilers that translate the existing code to the required target machine code on many different platforms. For example, a program written using Microsoft Visual Basic.NET may limit its execution to a Microsoft operating system, while programs written in C can be ported for use in Microsoft or Linux operating systems, with a few platform-specific code changes. Next is reliability. Reliability of an application is determined by the overall accuracy and the consistency of its outputs across multiple runs. Consistency is particularly important in reliability testing. A program may calculate answers very accurately, but if it cannot replicate this every single time it runs, it is not considered to be reliable. This is even more important in environments where people's safety depends on the reliability of a program, such as safety systems in a power station or collision detection in aircraft traffic control systems. Next up is robustness. Robustness is the measure of the program's code quality, particularly when the program is tested to ensure that extreme and erroneous data can be processed without causing the whole program to crash. So it will accept errors, but it will tell you that there's errors, but not actually crash the entire program. Finally, there is usability. Usability is a measure of how user-friendly an application is to use. If the principles of user-centered design have been followed, users will have been involved throughout the design process. Their ongoing evaluation will have helped to refine the design many times before being fully accepted. Popular techniques such as rapid application development permit the developer to quickly alter the layout, flow and interactivity schemes of an application to receive realistic interface feedback from the user. Although this form of rapid prototyping usually lacks the full functionality of the final product, i.e. it doesn't do everything of the final product, it does provide the user with a fairly realistic look and feel of the application quite early on in the development process, so they can get an idea of what the final program might look like and work like. Usability includes the program's inputs, navigation, and standard of output. The general appearance of the application can also have a bearing on this. For example, usability may suffer if the choice of colours or fonts is poor. Accessibility for users with disabilities or additional needs should also be considered when thinking about usability, particularly thinking about physical, visual or hearing impairments who might need the use of additional assistive technologies to use a piece of software. So, you've heard some theory about how to measure the quality of a software application. So the final task that you need to do in order to prepare for the assignment for Unit 4, Assignment 1, is going to be emailed to you. It's Worksheet 4.10, measuring the quality of a software application. What you're required to do is develop a questionnaire, a survey that would cover the 6 areas we've talked about: efficiency and performance, maintainability, portability, reliability, robustness and usability. So you're producing a set of questions that can measure the quality of a software application or measure the quality of a program. Now, to help you, what we've done with the assignment is given you an example of what question 1 could look like. Now, you should use different tools to collect the data that's both quantitative, which means something you can measure, so how many people agree, disagree or undecided, or use scales, which is also quantitative. So on a scale of 1 to 5, 1 to 10, how do you evaluate this, where 1 is poor and 10 is great, or 5 is great and 3 is half and half. So these are all quantitative measures, measures that you can give value to. Qualitative measures are measures where you give some written feedback or the user allows comments. So it gives you some detail to go with those numbers. So your task is to produce a questionnaire that can evaluate a piece of software, making sure you cover those areas of usability, robustness, reliability, portability, maintainability, and efficiency of performance. There is an example for what your question 1 could look like there. So did you find the application easy to use, is the question asked. That's obviously trying to measure usability. So then what you do is put in a little definition of what you're trying to measure. So in this case, question 1 is trying to measure usability, put in a definition of usability, and then how you're going to measure that answer. So in this case, it uses a scale, 5-point scale: strongly disagree, disagree, undecided, agree, strongly agree, and then you'd ask your users to choose one of the categories, and then you work out which percentage said each answer. So that's your task. To Worksheet 4.10, produce questions that would measure the quality of a piece of software. Questions should cover the 6 measures in order to evaluate quality of software. When you come to do your own program for this unit, you're also going to evaluate your program, and you're going to use this questionnaire, this survey, to evaluate your program. Okay, good luck with the assignment.